Hello everyone. Today I am going to discuss the fifth problem of AtCoder Beginner Contest 342, which is last train. So what is the problem? We are given n stations and also we have m trains. So a train is defined by these parameters L, D, K, C, A and B. So these parameters means that there is a train from AI to BI, or you can say that there is a train from A to B, and the train starts from equal intervals. So one train starts from lth time, one train starts from l plus dth time, and the last train start from l plus k minus 1 into dth time. Okay, now the train takes c time to reach from A to B. So let's say the first train will reach l plus c l plus c time to B. Okay, now what we have to find, we are given n nodes, n stations and m trains, and what we have to find, we have to find that f1 f2 up till fn minus 1. So what if1, what if means, so if I means that let's say we have some at some station is, and we are taking some path. So let's say intermediate 1, intermediate 2, and we are arriving at the nth station, and the timestamp here at the arrival of the end station, let's say, is tn, and the start is ts. We have to find we have to maximize, we have to find the ts value such that this tn is maximized for every source station. Okay, so let's take one example. Let's say let's take this example only. So let's say 2 3 let me show you this. There is a age from 2 to 3, and there is a age from 3 to 4, there is a age from 4 to 6. Okay, so let's say there are 6 stations in this problem. In this example there are 6 stations. So and here the time takes from the one train to arrive from the first station to third station is 3. Similarly, from third station to fourth station it is 2, like that. Okay, now let's try to find value of f2. Okay, so there are two paths where by which we can arrive from the second station to sixth station. The paths are nothing but 2 to 3, 3 to 4, 4 to 6, and another one is 2 to 5 and 5 to 6. So what is the time taken from this path, in this path? So let's say the time taken in this path is 4 plus 3 7. Okay, and the time taken in this path is 2 plus 2 plus 7 is 11. But that is not directly here we are just adding up the edges, the weights of the edges, right? But here you can see that there are other parameters values, right? There the one train starts from the third station to fourth station, let's say at l3 and l3 plus di, like that. Okay, so here you can see that the time takes from the second station to the sixth station is 67. Okay, so that's why the value of departure value of 2 will be, this ts value will be 56, and the there will be other path from 2 to 5, 5 to 6, the value will be definitely less. I think they have not calculated the value here. I am also not calculating, but because it will take a lot of time. So the optimal value, ts value, will be 56 here. That's why our answer if of 2 value will be 56. So you can calculate the other values. I am not going to explain each and every test case because it will take a lot of time. So let's jump into our observations. So what observations we can make? Our observations we can make is that the time complexity could be the value of n is 2 into 10 to the power 5. So time complexity could be either order of n or order of n log n. Here I am not considering m because n and m are similar, on the constants are quite similar. So you can also include the m part here also, order of n plus n, order of n log n plus m log n. Okay, so this is the optimal time complexity, order of n or order of log n. Now what is the similar algorithm we use for solving this kind of problem? Here you are seeing that there is some directed graph. In the example there is some directed graph with edges, or weighted directed graph, and we have to find the maximum time that we are taking to arrive from one node to another node. Okay, so here you can think about reverse of Dijkstra algorithm. So Dijkstra algorithm is used to find shortest path from a specific node. Okay, but here we are trying to find the longest path from one specific node. Okay, so let's say we have to find the longest path from any node to n. So instead of this graph, let's take the reverse graph. So let's take the reverse graph. So reverse graph will be nothing but the same graph with edges reverse. The weight will remain same, but the edges will reverse. Now we will have this graph, and in this graph, what we have to find? We have to find the time ts value, but we will start from the current node n. Okay. So now how we can solve this problem? Okay, now let me go through the Dijkstra algorithm once such that we will understand our current algorithm. Okay, so what we do in Dijkstra algorithm, we put the value of 0, the distance, we put the distance of source comma source in the set first, and after that we try to pop the first element or the minimum element from the set, and we try to iterate over all its neighbors. So what we do for I comma w in adjacency list of s. Okay, after popping the first element from the set, we do for I comma w in adjacency list of s, we do that distance, if distance of I plus sorry, not distance of w, I if distance of s plus w is less than our distance of I, we update the value of distance I and put it into the set. Okay, that is our algorithm, but here we are doing some reverse algorithm. So our this less than symbol will be converted to greater than symbol, but for this there is one trick, that instead of doing this thing, we can use this. Instead of using distance of s, we can use minus of distance of s, then our algorithm will work in the same way. So we are finding the shortest path, because we are reversing the or we are using the negative value, so this will give us the maximum thing. Okay. Okay, I hope you get it, because let's say we are comparing -5 and -3, so -5 will obviously be less than -3, and at the end we will print 5. Okay, so that's why we are getting the maximum value. I hope you get it. That is the first observation, that will be using Dijkstra algorithm. That's for sure. And the second thing is that we'll be using the reverse of Dijkstra. That's why we are using the same algorithm, but for the distance of something, we will be reversing it with minus of distance. Okay, that's the thing. The algorithm will be same, but here you can see that the w value is not constant. So w is depending upon the value of l, k, d, etc. Okay. Now let's say we are at some node. Let's say we are going from I to j. There is an edge from I to I to j. So what we are doing, that the edge will contain some parameters, that the parameters are nothing but l, k, D and C. There are four parameters for this edge. Now let's say the distance value of source is, let's call it as SO. Okay, distance value of source, let's say this is SO. Okay, now here we are seeing that something like we will start from L. So we are doing that L plus the number, the pth number of train will be L plus P into D. It will start from L plus P into D. Okay, and the time it will take will be C. So L plus P into D plus C should be less than equals to the distance of S, or distance of S, right? Now what will we do? We'll try to find this P value. So the P value will be nothing but P will be less than equals to source minus C minus L by P by D. Okay, so the pth train we will take. Okay, the pth train we will take. Now the value of P could be greater than K also. The value of P could be greater than K minus 1 also. So we have to take another condition, that the condition will be P should be less than equals to K minus 1. So after finding this, we have to take minimum of this and K minus 1. Okay, so this is the one thing. Then the value of the weight will be nothing but this value. Uh, the value of node will be nothing but from when we are starting from L plus P into D. So we are starting from L plus P into D. So our distance of I value will be nothing but L plus P into D. Okay, so that's the algorithm. Now let's jump into the code, and the code is also quite straightforward. So let's look at this. Okay, so here I am taking the input and here this distance of ai comma bi I don't think is required, so you can ignore this part. This is not needed. So I am I am forming the reverse graph a of bi. So I am putting a of b dot so the age will be from b to a instead of a to b. So let's say in the input this is given a comma b, so we'll be forming one age from b comma a with the same parameters. Okay, now I am forming the initial age. Okay, I am forming the initial age from the source node to the all the nodes that are going from source. I think this part can be done in the this loop also, but I have done this thing before. Okay, so you can say that this kind of pre-computation we are doing before entering into the our Digiter algorithm. So we are doing dp u0. U0 will, so u is considering what? So u is taking these values. Okay, so this is a l d k c. Okay, so the tuple will be nothing but a l d k c. Okay, so a l d k c. Okay, so that's why we are doing dp u0 is nothing but u1 is our l, so this is nothing but l plus k minus 1 into d. So we are putting the distance of the node that are let's say there is an age from n to, let's say there is an age from n to what call it, let's say q, let's call it n comma q. So we will put the distance of q is nothing but our l, the parameters of this age l plus k minus 1 into d, and we are taking the negative value of this to modify our Digiter algorithm to find the maximum path. Okay, so that's why we are putting dpu0 equals to l plus k minus 1 into d, and we are inserting it into the set. Now this part is the normal Digiter algorithm. The one thing that is changing here is this path where we are trying to find the start time of the current node. Okay, so this is nothing but p equals to ti. Ti is nothing but our SO value. This SO value you can call it ti also. So ti minus uh, ti minus u4 is nothing but c, ti minus c minus l, and if p is less than 0, this age is not possible, we are continuing, and otherwise we are dividing it by d, and after that we are taking p equals to minimum of p comma k minus 1. Now if the dpu0 value is uh, greater, or the node value is greater, we are just continuing, and otherwise this part is quite similar to the normal Digiter algorithm, and at the end we are iterating over all the values from 1 to n minus 1, and if the distance dpi value is infinity, we are initializing the dp array with infinities. So if dpi is infinity, then the nth node from the ith node is not possible, so we are printing unreachable, otherwise we are printing the negative of dpi value. Okay, I hope you got my explanation. The problem is quite interesting also. This is some modified version of Digiter algorithm, so you will understand, you have to understand that how Digiter algorithm work first. So I will provide the link of some Digiter article in the description box. You can go through that first before looking at the video. I will suggest you to look at the Digiter algorithm, because the problem involves some modification of Digiter algorithm, so that is needed. I will also provide the link of the code in the description box. If you have any doubt in any part of the explanation or code, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thank you.